Hello everyone, this is Dr. Young, and in this video we are going to continue our discussion about electron configurations, but talk about how some of the transition metals deviate from what you would expect for a normal atomic orbital energy diagram or these electron configurations. Right, so normally, right, just as a quick review, if I asked you to draw the atomic orbital diagram for boron, you'd go find it on the periodic table. You would see that it has 5 electrons. And you'd start filling your atomic orbital diagrams, right? So 1, 2, 3, 4, 5. And then to draw the corresponding electron configuration, you're like, okay, well, that's a 1s and it has 2 electrons in it. It has a 2s with 2 electrons in it. And it has a 2p, but that only has 1 electron in it. And here would be your electron configuration. So if that all sounds good, you're ready for this video. Let's talk about, well, what if you have a transition metal, and only certain types of transition metals, some of them have these weird little nuances to them. So the key point for this is that in general, atoms with a half full or a completely full subshell, d-subshell, appear to be particularly stable, right? So if you have a half full d-subshell, that means you're a d5, you're like 3d5 or 4d5. Or if you're completely full, that means you're like 3d10 or 4d10, right? That happens to be more stable than just being like d9 or d8 or d2 or d4 or something like that. And so what we see is that if you have a D4 or a D9 metal, they tend to promote an s electron in order to achieve a D5 or a D10. So let me show you what I'm talking about here, right? So here are my transition metals, right here in the middle. So we've got our transition metals. And if you look at these, right here, the scandium group is going to be all your D1s, the titanium group are your D2s, vanadium, that whole group is D3, chromium is D4, the manganese group is D5, iron group, those all have 6 electrons in their d orbital, the cobalt group all has 7 electrons in their d orbital, copper is the D9s, and zinc would be the D10s. So what we're saying here is that the D4s, which would be these, let me make that a little bit more. Right, so the D4s and the D9s, they tend to promote an s electron to have a full d subshell or a half full d subshell. So like if you looked at copper, right, and copper, our friend copper is right here. So copper, it has a atomic number of 29. So it has 29 electrons. I'm going to go ahead and draw the abbreviated electron configuration for this because there's so much there. So remember that means I'm going to start from argon and then talk about the electrons from argon, right? So I'm starting from argon and I'm going to go from there. This is group 1, or this is period 1, 2, 3, 4, 5, 6, 7. So if I start from argon, I'm in my 4s's, 4s2, 3d9 is what, if you just read the periodic table, what you would think copper is that it's 4s2, 3d9. However, right, you have to keep this in mind, is that this is a d9. Whoops. This is copper is a d9. It's in the d9 group, right? So it really just wants one more electron to become a d10 because d10s are particularly stable. d9s not so much. A d10, that would be really great. So it's just going to be a lower energy configuration if there's an electron at an energy that is also in this d orbital and that these are all full and there's all this great symmetry. If it can gain one more electron, it's going to be more stable. Where can it get that electron? It's going to sneak them from one of its s orbitals. So instead of having 4s2, it's actually going to be 4s1. All right, so this is actually going to change so that we're still going to start from argon, but it's going to promote an s electron. So now there's not 2 electrons in the 4s. Now there's only 1, but we're able to get a d10, right? So I've promoted up one of these electrons from the s up into the d orbital. It's going to make it more stable. And so that's what these transition metals kind of do. If I showed you this sort of more graphically with the atomic orbital diagram, what we're saying is that you had a 4s and you had your 3d subshell. And originally, you had 2 in the 4s, and then 3, 4, 5, oh, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we originally would think, right? That it's a 4s2, 3d9. That's what I drew. But what we're saying is that what you see is that you promote an electron. You're going to promote an electron from the 4s, so that one's gone now, and I'm going to draw it in purple just so we can see it, into here, so it's now 3d10, whereas before it was 3d9. So we still have the same number of electrons, right? There's still 11 valence electrons for copper in its outermost shell. It's just that we moved it from the S to the D. That's really it. And again, that only occurs with the D4s, so that they become D5 and they're half full. And it occurs with the D9s, so they become D10s, so they're completely full. Let me show you more examples. So now if we take a look at nickel, right? Nickel is here. Nickel has, let's see, 28 electrons around the periodic table. So nickel, again, we'll start from argon. We have the 4s2, and this is going to be 3d 1, 2, 3, 4, 5, 6, 7, 8. 3d8. And that's correct. I'm just going to leave that, right? Nickel is not a d4, and it's not a d9 transition metal. So I'm just going to leave it. I don't promote the I don't promote any s electrons. I just leave it alone, right? So all the rest of them, right? All the d1, 2, 3s, etc. You're just going to leave those alone. It's only the d4s and d9s that want to promote one. Now, if I go to chromium, chromium is number 24. It has 24 electrons. Here's our friend chromium. A similar idea. We're going to start with argon. Now that's going to be 4s2, and this is a 3d4, right? Because you go 1, 2, 3, 4 to get over chromium. And this should be where your little like mental alert sign goes off, right? Because it's a d4, right? It's a d4, which means we have to change this. I know that's not really that. I know that it's really going to have that s electron in a higher energy orbital. So 4s1, 3d5, right? And this would be the correct electron configuration for chromium. And then let's look at gold, which is Au, right? Gold is number 79. So it has 79 electrons. Gold is down here. So I'm going to start from xenon because I don't want to write the whole electron configuration. And this is row 1, or period 1, 2, 3, 4, 5, 6, 7. So we're starting in the 6s. 6s to 4f14. And then we are in 1, 2, 3, 4, 5, 6, 7, 8, 9. So then the 5d9. But again, this has a d9. And this was that example I showed you in the previous video where I said, oh, wait, gold does something funny, right? It's because it's a d9, right? So really this electron configuration I need to modify. I know it's not really that. I have to promote an s electron. So 6s1. I still have the 4f's. And then this is going to be 5d10, right? So still the same total number of electrons. I just promoted one of my s's so that I got a d10. And that's kind of the weird rule for some of these transition metals. That's really it. Just watch out if you have the d4s or d10s. So I want you to pause and see what you can do with these two examples right here. So pause, and I'll come back and help you out in a sec. Okay, so hopefully you paused and took a look at this. Here's molybdenum. So I'm going to start by drawing krypton, since that's the previous noble gas to it. And again, 1, 2, 3, 4, 5, 6. So that's my 5 s's. So 5s2, 4d, 1, 2, 3, 4. 4d4. So here's one of my d4s, right? So again, I know I need to change that because it's d4. I got to promote one electron so that it can have that half full subshell. For d5. Right, because remember, here with the d's, when we're looking at these 4ds, we had 1, 2, 3, 4. And what we're saying is that it's more stable when you have a half full shell. So that in this case, now it's 1, 2, 3, 4, 5, right? So with 5 electrons, it was able to have a completely half full shell, not just a weird partially full shell, right? So we're going for half full or completely full, where I'd have 10 in here altogether. Now, if I look at palladium, palladium is here. Also going to start with krypton. Also is 5s2. And here we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 4d8. And that's it. It's a d8. It's not a d4. It's not a d9, so I don't need to change it. That would be my correct electron configuration for palladium. So again, it's not all the transition metals that promote one. It's just the ones that need to in order to get a half full or completely full D shell. So practice those, and then the next video we're going to talk about ions. What happens when you start taking away and adding electrons, both to transition metals and to the more representative elements. So study up, watch the next video. Good luck.